Hello students, this is lecture number 1, chapter electricity, and today we are going to discuss about the basics of electric charges. To understand charges, let us consider two bodies A and B. These bodies are initially considered to be electrically neutral. When I say electrically neutral, that means body A and body B, in both the bodies there are same number of electrons and protons individually. That means if body A is having same 7 electrons, so it will have 7 protons. Body B is having 10 electrons, so it will have 10 protons. This is just an example. So both of these bodies are considered to be electrically neutral. While protons and electrons, the charge of proton is plus 1.6 10 to the power minus 19 coulomb, and the charge of electron is minus 1.6 10 to the power minus 19 coulomb. When we add both of these charges, the net charge becomes equals to 0. So inside the nucleus there are 3 elementary particle trays: proton, electron and neutron. Inside the nucleus we have proton and neutron bonded with the nuclear forces, and the electron revolves around the nucleus. Suppose if I transfer one electron from body A to body B, there are so many methods for electrification that we'll discuss little later. So suppose if I transfer one electron from body A to body B, then body B becomes minus 1 E charged and body A becomes plus 1 E charged, because body B will have one excess electron because it is gaining electron, and body A will have deficiency of one electron with respect to proton. If I transfer two electrons from body A to B, body B becomes minus 2 E charged and body A becomes plus 2 E charged. Similarly, if I am able to transfer n number of electrons from body A to body B becomes minus n E charged and body A becomes plus n E charged. So if we see here, body B is having excess amount of electron and body A is having deficiency of electrons, so body B becomes negatively charged body and body A becomes positively charged body. So the charge can be defined as the net excess or net deficiency of electrons in a particular body. Body gaining electrons or having excess number of electrons will be termed as negatively charged body, that is body B, and body having deficiency of electrons are considered to be positively charged body, that is body A. Charge can also be defined as it is the property of the body which allows the electrical interaction between two bodies. When we say electrical interaction, there is the very important property of charges, that is property of electrostatic force. Electrical interaction means if two bodies are charged and if they are having like charges, positive or negative, then there will be a repulsion between these two charges, like charges. And when there will be opposite nature of charges interacting with each other, so they will attract each other. So like charges will repel each other and unlike charges attract each other. In the very first diagram, when we are discussing about the transfer of charges from body A to body B, and in the last we discussed this key, when n number of electrons will get transferred from body A to body B, then body B becomes minus Ne charged and body A becomes plus Ne charged. Here n should be an integer. That means it is not possible to transfer half electron or 0.25 electron or 0.75 electron from body A to body B. So this n should be an integer, and this property is called quantization. This is the charge acquired on a body, and it can be indicated by small q, that is plus q, and this will also be q, but it will be minus q. So the second very important property of charges is now this property of quantization says any free charge. In the previous page we have seen that charge acquiring on body A and body B is q. So any free charge can be expressed as the integral multiple of that. This is the number of electron and it should be an integer. Integral multiple of the basic unit of charge, that is charge of electron, and we know the magnitude of charge is 1.6 10 to the power minus 19 coulomb. So any free charge can be expressed as the integral multiple of basic unit of charge, that is charge of electron, and this is the property of quantization of charge. One very important thing to understand about the quantization of charge is The concept of quantization is valid only at microscopic level, where the number of electrons ranges from few to few hundred. That means if you see these two diagrams, here the number of electrons we can count easily. These are discrete in nature, and this is called the quantized distribution of charges. But here the particles or the charges are so close and they are so huge that we won't be able to count this. So this type of distribution is called continuous distribution of charges, and this is the part of class 12th physics curriculum. There we have linear charge distribution, surface charge distribution, volumetric charge distribution. So these kind of distribution we'll have. So the concept of quantization is valid only at microscopic level, where the number of electrons ranges from few to few hundred. For example, if we take this example, in this example, if you see, suppose you have to form a charge of 1.6 microcoulomb. This will be 1.6 to the power minus 6, not minus 19. So if you have to find the number of electrons which should be combined to form this amount of charge, 1.6 microcoulomb, which is a very small charge. So from the equation of quantization, Q is equals to Ne. E is the basic unit of charge, that is charge of electrons. So you will put 1.6 10 to the power minus 19 coulomb. Q is given 1.6 in 10 to the power minus 6 coulomb, that is 1.6 microcoulomb. So you will get N is equals to 10 to the power 13, which is so huge in number. So in this case, the concept of quantization is not valid. So we can note here this concept of quantization is valid at microscopic level, where the number of electrons ranges from few to few hundred. So this is all about lecture 1. In this lecture we discussed about the basics of charges, that is the net excess or net deficiency of electron is called charge, or it is something which allows the electrical interaction between two bodies. Two very important properties of charges we have seen: electrostatic force, like charges repel each other, unlike charges attract each other. And very important property of quantization of charge, that is Q is equals to plus minus Ne. This is the quantization equation of charge. In the next lecture we will discuss two more important properties of charges. Thank you so much.